And we will continue with the next thing. First, we did the dimensional table details, okay? Because we know the dimensions, let's say, okay, the date dimension and the product dimension and the store and the, the cashier or the employer dimension. But what is there in each one, we did not discuss, okay, in detail. So the date dimension, we discussed briefly that it is a very important part of any business model, date, whether it's hoteling, whether it's a restaurant, whether it's flight system, traveling system, government processes, tawakkalna, vaccination, sahati, mawa'id, whatever you call it, date must be there, okay? And we saw different examples in the date. Not all processes have these things. And you can see there is also dot, 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 which means that there can be many other things, okay? But it depends. In simplest case, you will have only the date, for example. In the very simplest case, you may not even have the day of the week, but in other cases, you may need that. In the financial institutions, this may be important because for different types of analysis, it is important whether you are in the first quarter of the year or second quarter, etc., and so on. Okay, so this is the example of date table. And we also said that the date table can be generated in advance because we know that, let's say in 2030 on March 20th, what will be the day and so on. Okay, so this information is available for centuries for you, for example. But normally we don't think about centuries. We maybe think about 10 to 20 years. Okay, even we don't think about 50 years in advance. Okay, so that's something which is available as date dimension. Okay, after that, the next thing we wanted to discuss was the product dimension. Okay, and we already say that we know about SKU, which is the stock keeping unit. Okay, so the product dimension describes every SKU in the grocery store. Okay, in your store, it is about all the things that you sell in the grocery store. So it's about, once again, butter or milk or coffee or perfume or pens or cups, mobile phones, whatever it is. In the grocery store, normally, typical grocery stores, you will not have some electronics. Okay, very basic electronics may be there, but in big grocery stores, you have electronics department. Okay, you have the fish and the meat, different departments, etc. Okay, so the product dimension may have 300,000 or more rows. Normally, we say it in the beginning, and here also you see that it can be 60,000 at any time. But because some products may be there in the past, let's say last year there was a product which is not available now, or they changed the design, they changed the price, etc., maybe for some reason. So that thing has a different SKU, or that thing is gone now, it has a replacing thing, but the previous information is available. Because in the data warehouse, remember, we don't delete anything. So if something was available 5 years ago, still it's part of the data warehouse and it will be there. In this way, although the current product is, let's say, the quantity is 60,000, but if we consider even the past products, that may be 300,000 or more rows. Okay, so flatten many-to-one hierarchies. What does that mean? Okay, many-to-one hierarchies. We need to understand that. Now, SKU is the atomic, information, the atomic data. Okay, for example, product name and individual product. So here is, you see the SKU for baked, well-light, sourdough, fresh bread, for example, and so on. These are 9 different products. The product key is here, in this case, an integer. It's not some code, for example, BW567. No, it's 1, 2, 3. Why do we use that? I will come to this after a few minutes, but here we see the product key as an integer. The product description is the name of the product with some basic description capabilities. Brand is the brand of the product. Okay, what type of brand? This is the company. And the subcategory is, for example, fresh or prepackaged, ice cream, novelties, etc. These are the subcategories. Then you have a category for that. This is the bread category, the sweetened bread, the frozen desserts, etc. Okay, frozen desserts. And then the department description after the category, you can see that these 2 categories, they are in the same department of bakery. Okay, then you have another department, and finally there is also the thing related to fat content in that, whether there's reduced fat, regular fat, non-fat, etc. 3 or 4 different types of fat content in that. So what do we see from this table? This is a sample, some sample rows from product dimension, which are these things. Now we come to the many-to-one hierarchies. This is the point, okay? So every product is unique, okay? Here, no product can be repeated in the product description, that for sure. But a brand may be repeated, for example, fluffy, okay? Similarly, 2 or more brands, they can be in the subcategory. For example, prepackaged has the brand of light and fluffy. Then you have categories. You can see that the bread has different subcategories and so on. Okay, so this, what you see here is that, for example, one department can have many subcategories, categories. The categories can have subcategories. The subcategories can have brands, and the brands can have products. Okay, so this becomes many-to-one, many products in one department, for example, or many products in one brand, many brands in one subcategory, many subcategories in one category, and so on. So this becomes a hierarchy, like a tree structure. At the top you have department, then you have branches, and then you have sub branches, and so on. Okay, so this is the concept of roll up and roll down. If you remember from the video, okay, that we have from main category into subcategory. So you roll down into different categories, or when you roll up, it means that from individual products, you move up to the super category or the main thing. Here, the last or the root of the category is the department. Okay, so SKUs, they roll up to brands, they roll up to categories or subcategories, and they roll up to the department. Okay, so this becomes a many-to-one relationship. From the product to department, there are many-to-one relationships. I hope this concept is clear. What is many-to-one relationship in this case? Okay, this is different than the many-to-one relationship in the entity relationship models. Okay, this is because we are in the categorization or the subclassing. Okay, so the super and the sub categories. Okay, so for each SKU, all levels of merchandise hierarchy are well defined. This is very important. Okay, so it's well defined that, for example, let's say you have cells, bataria. Okay, so it's in the electronics main category department, but within the electronics, there may be chargers category, maybe there is some batteries subcategory, etc. There is the brand category, like, okay, and the type, for example, small or big, etc. So this is well defined. Where are the hierarchies? And of course, those people who are expert in the shops or the grocery stores, they know which category is where, and they can help in identification of that. Okay, so the SKUs, they are unique. As I discussed, that you cannot repeat a product description of the SKU. Okay, so on the other extreme, there are only perhaps 50 distinct values of the department. Yes, so department cannot be, let's say, more than 50. Electronics, frozen food, bakery and vegetables, and you know, dairy products and something else. They may be at most 50, for example. Okay, so at one hand, you have 300,000 different elements here. On the other hand, there are only 50 things here. And this is something which we consider, you know, in case of normalization in the database course, that we need to normalize those things. But here, what's the thing? On average, there are 6,000 repetitions of each unique value in the department. This is repeated on the average, just about 6,000 times. Okay, in one department, you may have, let's say, on the average, 6,000 different types of SKUs. This is perfectly acceptable. Very important point. This is not acceptable in databases. In databases, when there is repetition, we normalize to avoid repetition. I repeat, okay? In databases, we don't repeat things. We avoid that by creating normalization. So first normal form, second normal form, and then third normal form, etc. We do all of these to avoid repetition. But in this case, in dimensional model, what we say, this is perfectly acceptable. This is totally fine, no problem. You do not need to separate these repeated values into a second normalized table to save space. Okay, if there is repetition, that is totally fine. Okay, Remember this important concept, okay? And we will come to this point again as well. So you can see product dimension table like here with some further details. It's like this. You have the same product key, okay, which is actually like 1, 2, 3, etc. Then SKU number, okay, we call it natural key. So product key is the the primary key, okay. This is PK, a product key, and PK is the primary key, and this one is a natural key. So the natural key is something which is assigned uniquely to each item, but here the book says, or according to the dimensional modeling, we will not use the SKU number as a primary key. Why? Because they give us some reasons that we should not use that. It creates some problem of joining, etc. It makes it complex. So product key is a separate unique key, and usually it is an integer key starting from 1 until whatever the total number of products is there. Then product description, brand, subcategory, category, department, all those things we discussed previously in the sample rows, but there are even more things, and they can be so much. They can be, let's say, hundreds or maybe 50s. Okay, so the product dimension can have so many things, and many of these will be repeated for this dimension. Okay. Okay, now rolling up or rolling down, we already know it is moving from subsection to section or from section to subsection. Roll down means you go from up in the hierarchy down to the hierarchy, that is rolling down, and rolling up from down the hierarchy from details into the higher level, that is rolling. Now here is drilling down on dimension attributes. Okay, what is drilling down? We already have some things here. Let's see, it's the same thing. A reasonable product dimension table can have 50 or more descriptive attributes. For example, as I said here, these are the descriptive attributes. These attributes, they describe your product, so they are known as the descriptive attributes. Now, these descriptive attributes are different than the fact attributes, which are in the fact table. What are the fact attributes? For example, item quantity. Okay, how many quantity of items of particular item have been sold, item price, unique, etc. These are known as the fact. So here we are talking about the descriptive attributes. Product can have 50 or even more descriptive attributes. Each attribute is a rich source of for constraining and constructing new header labels. Okay. So header label is the label for that attribute. Okay. Drilling down is nothing more than asking for a row header from a dimension that provides more information. Okay. So which means that we need different levels of information, and drill down means to go into the detail of that information. Let's see the example. Okay. Drilling down in a multi-dimensional model is nothing more than adding row header attributes from the dimension tables. Drilling up is removing row headers. You can drill down or up on attributes from more than one explicit hierarchy and with attributes that are part of no hierarchy. Okay. So what are the hierarchy attributes? For example, from dimension to subdimension and so on. Okay. So in this way, actually drilling down is same as roll up or roll down. What you see here is the example. The first, here is the department name. For example, bakery is one department, frozen food is another department, and this is sales dollar amount for bakery this much, and frozen food is this much. Okay. Now this is the up level, the department level. We can drill down by brand name. From department we go into the brand name. So for example, from the bakery, one bakery is divided into 3 brands here. For example, we have, let's say, 3 brands, and the frozen food, one department is divided into those. So drilling down gives us, it's the same thing as roll down here. We have 12,331, which actually comes from here. Okay. So these 3 combined, they will give us 12,331, and the remaining, these 5, when they are combined, they will give us cumulative or total sales for the frozen food of 31,000. Okay. So drill down by brand, we go into the sub drill down after department, we have the subsection, which is the brand, and here we drill down by fact content. Okay, so in the bakery, for example, non-fat, reduced fat, regular fat. Similarly, in the frozen food, we have non-fat, reduced fat, and regular fat. So all the possibility in the fat contents for each department, this is the drilling down. So drilling down by brand, we specify the total number of brands. For each brand, how much is that sales amount? And drilling down by fat, we have for each type of fat content, the sales in dollar, etc. Okay, so and it is important to understand the drill down. Now, if we have this thing and we want to drill up, so of course we will combine, we will remove the fat content and we will go into the department, and then we will combine all those three in the bakery, and we will get this thing as drilling up into the department, for example. Okay. Okay. Then we have the store dimensions. Okay, there are some details about stored you can see, and this discusses the topics of multiple hierarchies. Okay, but it's not important understanding just the date dimension and the product dimension is enough for us for this chapter. Okay, I think we don't have further dimensions in here. Let me check that. Yeah, so promotion dimension is another dimension. Okay, which include temporary price reductions, for example. Okay, so price reduction temporary maybe because of certain reasons. For example, sometimes there is a product which is going to expire very soon. Okay, it has 1 month or 2 months, and you cannot put it in the shelf because it may be expired, and you cannot sell the expired things. So you want to sell that product before the expiry date. Okay, so you will have a price reduction for that. For example, you may say that buy one, get one free. Okay, then there is end aisle displays. What is end aisle display? At the end of, there are those rough at the end or the start, you have some particular display at one end. So they are attractive because the people, they move around the aisle or the aisle, okay, and they actually see those products. So they have higher rate of purchase by the people because they can be seen from a distance. Okay, so that's also particular displays, and those things, they have their own prices, for example. Then there is promotion for newspaper ads. Okay, in the newspaper, you give the ads, and they maybe have coupons, for example, coupon code, etc. So they have their own promotions. Then, okay, coupon code is there. So this dimension is often called a causal dimension. Okay, because it describes factors thought to cause a change in product sales. They cause a change in the product sales. So any type of promotion, they will change your sales. So when you apply a promotion to something, they will increase the sales because the people will buy it more. Okay, buy one, get one free, buy two, get one free, etc. 20% discount, okay, or weekend discounts, etc. They are the causal dimensions. Remember this thing. And you see there are different factors for promotions, and they are described here, like lift, which is something. Then there is time shifting, then there's cannibalization, market growth, and so on. They have defined some things, but they are purely about business dimension. Okay, I mean, for business students, that's fine, but from computer science point of view, it is not very important. So I just highlighted that for your information. I'm not going into the detail, and I'm not asking you. If I ask you, it will be in the assignment, but not in the exam. Okay, so we just need to understand the promotion dimension, that it has its own dynamics, or it has its own, strange things which are different than the product and which are different than the date. Okay, so the various possible causal conditions are highly correlated. Sometimes causal condition is season, for example. You see, usually, for example, Center Point or Max, they have end of season sale. So right now, for example, winter has gone almost. Okay, so they will have end of season sales, and they will sell all those things at a discount price which were used in winter. Now, people normally don't buy those things because they know that maybe next year we don't need them, and maybe next year the fashion is different. But some people who are needy, or sometimes some things you like so much that on a discount price you will buy it. So why they offer discount? Why don't they keep it for next year? The reason is because, first, they don't want to, use their space. They want to get rid of those things, even at a discount, so that at least they will be gone. Okay, they will have new things. Second, because people may not buy them next year because of new things, new fashion, new designs. Okay, so it's better that in one season, when you have things remaining, you put them on the sale, and this is usually the end of season sales. Okay, so the end of season sales and some other promotions, they may be highly correlated. Okay, they will have a correlation with one another. They will have some dependence with one another. Okay, so a temporary price reduction usually is associated with an ad and perhaps an end aisle display. Okay, so an end aisle display is one type of promotion, and there you will put the temporary sale price things because it is more visible. So you know that these things are going to be expired soon, so you put that in a place where people can find it easily, or where it is more attractive for people to be there. Okay, so for this reason, it makes sense to create one row in the promotion dimension for each combination of promotion conditions that occurs. So what are the promotion conditions and combination? The combination is that one item may have, let's say it may appear in the ad, newspaper ad, it may have a reduced price, and it may be in the aisle. So we will put all those conditions for that thing. Okay, so this is one way of having a promotion. So this gives us some idea of conditions for promotion, and then we will see how does it look like in the next page. So from a purely logical point of view, you could record similar information about the promotions by separating the four causal mechanisms. What are the four causal mechanisms? The price reduction is one thing, ads is another, displays is another, and coupons, this is another way. So for example, Pandas, last month Pandas has coupon system. So when you buy something in February, they say that you get a 50% reduction if you buy in March. If you buy something more than 200 reals, so you will get a coupon of 50 real reduction. Now that was something which was a coupon. Okay, so what we have is that we could record this into separate dimensions rather than combining them into one, but this has some problems. Okay, it explains why we should keep all of them into one dimension instead of having separate dimensions. So at the end, the promotion dimension, it looks like this, that you have a promotion key, which is a primary key. And once again, I tell you that this is what? This is a, what should I say? An integer. This is not a natural key, okay? There is no natural key for promotion, but there is a primary key, which is 1, 2, 3, something like that. Then you have promotion code. Yeah, promotion code can also be a primary key, but I told you we don't use that, okay? And it is explained shortly. Promotion name, for example, winter sale, summer 2022, or end of season 2022, something like that. Price reduction type, is it, for example, buy 2 get 1 free, or is it 25% or 15% discount? Promotion media type, whether it was in the newspaper, whether it was in the social media, etc. Ad type, okay, there are some things. Display type, whether it was on the wall, let's say it was in the entrance or the door of the shop, or whether it was on the television or something like that, okay, and so on. There are different things, and it can be, again, many things, but we have a promotion dimension. Okay, next, there are other retail sales dimension. Okay, we studied only promotion, product, and date, but there are many more. Okay, and we go to retail schema in action. Okay, so now we are talking about the whole schema. We have discussed some dimensions. Okay, let's illustrate how it would be put to use in a query environment. How would we have a query on this schema? Okay, so you can see the schema is something like this. We have different dimensions: product, promotion, payment method. In payment method, you have the payment method key, which is the primary key. Then you have description and the group, which type of method group is there. Okay, so there are different dimensions. In the center, there is the fact table. So this is a star schema, you can see. I repeat, this is a star schema because at the center, you have one table and the remaining tables, they go out from the center. Now, for some of these, there is some example. For example, for calendar month, there is example of January. For calendar year, 2013 example, store region, Boston, and category description is snacks. This example tells that you can have these types of, things. For example, you say that give me all those products which are in January 2013 in the Boston region and from the snacks category. And it can be, because Boston region, so it can be all the stores in the Boston region. Okay, so you can combine those values from these dimensions to have a query ready for you. Okay, so this is an example of thing. Okay, now here is one thing. Query results and cross tabular report. Okay, what are the query results? You can see that the month is January, the date is the year is 2013. Okay, and the promotion name, if there is any promotion, no promotion, then there is Super Bowl promotion, and extended sales dollar amount is this thing. Okay, query results, and this are the query results. Cross tabular report is actually across different queries, but we don't discuss that cross tabular. So just for example, from this type of fact and dimension table, we get this thing. This provides an analysis. So this is about particular month and year, okay, for particular promotion or without any promotion, and what are the sales amount from this. Okay, there is more about sales retail schema extensibility. You can extend the schema. Okay, but let's see. Okay, the topic of we are moving towards the end, which is the factless fact table. Okay, what is factless fact table? A fact is something that you record when there is an event, remember. So when a customer buys something, a fact is recorded. For example, what did he buy? Where did he buy? At what time he bought? Okay, who was there? The cashier. Okay, what was the product, etc. That is a fact. But we see that there is an important question that cannot be answered by the previous retail sales schema. So what question cannot be answered? The question is, what products were on promotion but did not sell? Okay, what products were on promotion but they were not sold? Of course, we cannot, record that. Why? Because we are only recording the things which are sold. If something is not sold, we don't have any record of that. Understand this point? Okay, so factless fact table means that we need some facts which are not recorded. What should we do? Okay, let's see, there are some examples they explain, but it's we will see that if you work with data in an OLAP cube, it's often easier to answer the what did not happen question, because the cube contains explicit cells for non-behavior. Non-behavior means something that did not happen. So when you did not sell anything, it is a non-behavior. So in OLAP cube, you can answer that. That's the another important part of the dimensional modeling. Okay, so here you can see the promotion coverage factless fact table. What is that? What is the promotional coverage? What we had is that the date dimension, because of the date dimension, we record every day, and because of this recording, we will have which promotion was there and so on. Okay, so the detail is there. Okay, and not here, but in the next lecture, we will see the factless fact table in another way. Okay, and there will be some other example. Okay, okay, now I come to the point of, why we had the primary key as integer numbers. I told you many times, okay, that we will discuss that there is one type of primary key which is known as natural key. Okay, for example, code, product code, but we don't use the product code as our primary key. Okay, instead we use the integers which are known as the surrogate keys. Okay, we don't use the operational identifiers such as the natural key, but we use surrogate keys. So surrogate keys are simply integers that are assigned sequentially as needed to populate a dimension. So the first product is assigned surrogate key of 1, the next is 2, and so on. Okay, and that's why in this example, where was that? Let's see the example. The table example was very quickly. Yeah, here you can see the product key is a surrogate key, which means that we start from 1, 2, 3. We don't use some specific code. And the reason it describes is here. Why do we have surrogate keys? The surrogate key also doesn't have any business significance. Like 1, 2, 3, it doesn't serve anything. Okay, it's just a number. Okay, but they are used to join the table, and they are better than the other primary key or the natural key. Okay, because it does not contain any information about, you know, the time or the season, etc. It is just a number. So joining on the basis of a number is better than joining on the basis of some identifier, which contains some information. For example, W may be for winter, S may be for summer, something like that, okay, in the code, which is not good. So they encourage us to use the surrogate keys. Okay, so every join between dimension and fact tables in the data warehouse should be based on meaningless integer surrogate keys. Okay, you should avoid using a natural key. That's the recommendation, and we should use that. And there are some examples or some explanation of why we should use the surrogate keys. Okay, so I think this finishes the topic. There are many more details out there. Yeah, last things. Okay, this is also very important. I discussed with you the star schema a few pages ago. I told you that this is the star schema. Now we are moving towards the snowflake schema. And we have seen the example of stars schema and this snowflake schema. But here we are studying this from the book. What is that? Okay. Now snowflake schemas with normalized dimensions. Okay. What's the concept? Let me first tell you the concept, then we will read. The concept in dimensional modeling is that you have dimensions, okay, different dimensions. And from these dimensions, you take the primary key from every dimension, you put that into the fact table. And in the fact table, you have other attributes, which are known as the facts or the measurements. Okay, that is the basic thing. And this fact and dimension table schema, it becomes a star schema. So one fact table with many dimension tables. Now there is no normalization. And we saw the example that a department or a category is repeated many times, but we don't create another table for that. If we want in a database design, so what we will do, we will create a separate table for for each brand or for each department, and that will be referenced to the foreign key or primary key from the another table. Okay, so in the dimensional modeling, what we discussed in the fact table, there is no normalization. Now, what we are discussing here is the possibility of normalization. If you want to normalize, what will happen? Okay, and that's very interesting. You should read it. Okay, I repeat that you should read this topic. It's just maybe a couple of pages, but it will be worth understanding. So dimension tables normalization is referred to as snowflaking. Okay, if I could draw, I'm not sure. I think I cannot draw here. Yes, but the thing is, star schema has one central table and then dimensions. When we normalize the dimensions, so each dimension may be 2 or more tables. It means that from a simple star, it will have branches, and it will give rise to a structure which is known as snowflake. Okay, so a snowflake is a structure. Let me show it to you here even. If we see here, snowflake, you can see that like this is a fact table, then there's dimension. From this dimension, we have 4 more, and from this we have more, like, okay. It creates what? Children. So it creates a hierarchy. And this is more than the simple, star schema. Star, we know it has just one center. Like if you consider this as one branch. So this is a star, let's say. We don't consider the sub branches. And this becomes a snowflake because one table is divided into further tables, okay, because of normalization. So this process in which we normalize the dimension table, this is known as snowflaking. I hope you understand my point, okay? Very simple point. Normal dimension table is a star schema, but when we try to normalize it, we get snowflake schema, and that is the main concept here. So it says that if you have, normalization for all the dimension tables, it will become very big. For example, consider this figure 3.12. What will happen if the hierarchies were normalized? Let's go to 3.12 and you will see this 3.14, this is 3.12, okay? So if you normalize this one, what will happen? If you normalize this one and you normalize this one, so there are 6 dimension tables. If you try to normalize them, they will give rise to actually see so many, things. So where were we? Okay. And here is just the product dimension, which is normalized. Okay, only one dimension if you normalized. So from this product dimension, you can see the brand. Okay, so brand dimension is created, which is subcategory of product. From this brand, we have category. From category, we have department. Okay, similarly, we have package type dimension. Then we have storage type, and within storage type, we have shelf life. So this is connected to one fact table. Okay, one fact table product. Then with the same fact table, we have the date and so on. So if you create, normalize all those dimensions, so it will be so many tables and it will become, very impractical. So what's the advantage or what's the disadvantage? Well, we see that snowflaking is a legal extension of the dimension, which means that it's not a problem. Okay, however, we encourage you to resist the urge to snowflake, which means that we don't want snowflake. Why? Because if you go to snowflake, you will have the problem that if it is not snowflake, if it is star, then that will be ease of use. It will be easy to use, and because people will understand. So it's easy to understand a simple schema like this. Okay, it's easy because you see that this is the facts and then this is the product. Okay, so everything is there. But if you see this type of categorization or normalization, it becomes difficult to understand. The second thing is performance. If you have this type, you need joins. Okay, and joins means that you slow down the progress. Okay, it loads many tables and so on. Okay, so joins slows down the thing. Okay, and if you don't have any joins, you just have one product dimension, you will get the data directly in one row. Otherwise, the joins will slow down the performance. So 2 reasons: ease of use. Okay, in non-normalized, the star schema is very easy to see. Okay, and the performance is good. And the normalized one is difficult to see, to understand. Okay, particularly for computer users or for the business users, it's difficult, and also it has slow performance. Okay, so here there are about 5-6 different reasons why is a snowflake tables not good, because they are much more complex presentation. That's one reason. Because business user, most database optimizers are the query optimizers. They will also struggle with the snowflake schemas. Okay, so this is software issue. Okay, it's difficult to optimize, but star schema don't need that optimization. Then the diff space savings. Why do we do this? Because we want to avoid the redundancy. And when we avoid redundancy, it means that there will be reduced disk space usage. Okay, so that's a benefit. But this benefit is not that much because it's so minor. Here it gives an example that if you replace the 20 byte by 2 byte, you will only have 5.4 megabyte of reduction, which is nothing. 5.4 megabyte of less memory is nothing for you. So it's not very important. Okay. Similarly, the important thing is this: reduced ability of the user. Users cannot browse within the dimension, okay, with snowflaking, okay? And there are some other things as well, okay? So that is about the snowflaking, and I think this was the last topic. Yes, one more, sorry. I thought it's the last topic because I prepared this before the exam. So I did not remember where are we going. Okay. I hope this is the last topic and we are going to stop. Okay. Centipede fact table. What is centipede? I think this is known as alaqa or what? Centipede. The insect which has about 100 feet, for example, that is known as centipede. Okay. So centipede fact table is what? A fact table which has so many like dimensions. Okay. Too many dimensions. And the example is this one. Okay. Now you can see this retail sales transaction. It has so many dimensions here, 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 here. Let's say if this is the case, what will happen? What is the thing if there are too many? And it is because of normalization, because you normalized, so you got this thing. Okay, instead of just one dimension, which was the store dimension, we have the store and store county and store state, etc. We normalized this, so we got so many things here. Instead of just promotion, we had these things. Instead of just product, we got those all with the product and so on. Okay, so this becomes like a centipede. Okay, and this centipede is what? Is it useful or not? So designing a fact table with too many dimensions leads to significantly increase fact table disk space requirement. Okay, now it is not like directly normalized because we store everything here, but all the detail is here. Okay, so it means that this has so many columns, and this will create a disk space requirement. Now, previously, we said that disk space is not a big issue. Yes, it's not a big issue for dimension table, but it can be an issue for fact table. Why? Because dimension table is very small, but fact table is your largest table by orders of magnitude. A fact table may have millions. A dimension table may have a few thousand. Okay, like we said that a dimension table may have product dimension may have 60,000 things, which is not a big thing in database. But every transaction, every user comes, and maybe every user has hundreds of items. So a single user may add 100. If there are 1,000 users, that may have 100,000 in a single day in one store. Now, if there are 100 stores, there are millions in one day. In 1 year, they maybe have several millions, and similarly, you can go to billions in an year or so. So in that case, if you have a table like this, that will be a huge, storage problem. Okay, and that's not good. So the idea is not to have something like this. Okay, so most business processes can be represented with less than 20 dimensions in the fact table. Okay, if a design has 25 or more dimensions, then you should look for ways to combine correlated dimensions into a single dimension. Okay, so correlated dimensions, like for example, all information related to store, region, district. Okay, like this is high, and after high, this is mantaqa, etc. So you can put them in one dimension table, okay, store dimension, instead of putting all those here. So this will reduce, the number of attributes in the fact table, and that will be very efficient. Okay, that's the main point in here. Okay, so this finishes chapter 3, which was about retail sales. Okay, next time I will have another types of slides which will repeat the same concept with different examples. Let me stop the recording.